Good afternoon and welcome to today's Green Chemistry and Commerce Council webinar entitled Industry Academia Collaborations to Advance Green Chemistry. We will start the webinar in just 1 minute. Good afternoon and welcome to today's Green Chemistry and Commerce Council webinar entitled Industry Academia Collaborations to Advance Green Chemistry, Steelcase, and UC Berkeley's Greener Solutions Program. My name is Joel Tickner and I'm the Director of the Green Chemistry and Commerce Council. I'd like to welcome you to today's webinar. So for those of you not familiar with the GC3 or Green Chemistry and Commerce Council is a business-to-business cross-sectoral network of over 100 companies and other organizations dedicated to accelerating green chemistry across the value chain and across sectors. Our over 100 members include major retailers, major chemical manufacturers, brands, other manufacturers, and a number of academic and government partners as well, and nonprofit partners. So today's webinar highlights a key theme that has run throughout the GC3's last 12 years is partnerships, collaborative partnerships to accelerate green chemistry. At our Innovators Roundtable 2 years ago, we highlighted a similar collaboration between the University of California, Berkeley Center for Green Chemistry and Method. And today we're going to highlight one between the UC Berkeley Center for Green Chemistry and Steelcase, one that is a great example of the ways that academic institutions can work with industry and share resources to accelerate the design and application of safer materials. And of course, our roundtable, which is in 2 weeks at Steelcase. This is a great entree into the roundtable. So we have 3 speakers for today's webinar. We have Tom McKeag, who's the Executive Director of the UC Berkeley Center for Green Chemistry. And Tom will be talking a little bit about the UC Center for Green Chemistry. Tom is the current director, and he's the founding editor of the Zygo Quarterly magazine. He's taught the BioWorks Studio course in industrial design at the California College for the Arts. And he was a Fulbright Nehru Scholar at the Indian Institute of Science in Bangalore, India. John Smieja is the Sustainable Design and Development Leader for Global Sustainability at Steelcase. He received his bachelor's degree in chemistry from the University of St. Thomas and his PhD in inorganic chemistry from the University of California, San Diego. And John started Steelcase in 2013 as a member of the materials chemistry team within the Global Environmental Sustainability Group, where he served as the environmental chemist for 3 years before moving into a role as a leader in the Sustainable Design and Development Group. His role at Steelcase involves collecting materials chemistry data from suppliers, evaluating that data against human and environmental health criteria, working with suppliers to eliminate chemicals of concern, working on material innovation projects, and communicating with customers in order to provide transparency about Steelcase's products. And Mark Shapero is a graduate student at UC Berkeley. He's a PhD candidate in physical chemistry, and his doctoral research focuses on the photochemistry of hydrocarbon combustion radical intermediates. He has his undergraduate degree from Queen's University in both physics and chemistry. So as I mentioned, this webinar is a preview of the 12th annual GC3 Innovators Roundtable, which will be hosted by Steelcase in Grand Rapids, Michigan in just 2 weeks. The day before the roundtable is our second green and bio-based chemistry technology showcase, also in Grand Rapids. If you haven't registered for the roundtable, we encourage you to register and come to the roundtable, as many of the themes that you'll hear on today's webinar will carry over into the discussions. Just a point of logistics for today's call. All lines on today's call will be muted. If you do have questions after the presentations, there is a question and answer box in the control panel on the side of your screen, and we'll answer those questions at the end of the presentations. So with that, let me pass control or pass over to Tom, and welcome Tom to the webinar today.
Well, thanks very much, Joel. It's really a pleasure to be part of GC3 and part of this webinar today. We want to thank you and Jennifer for setting this up for us. Also, hats off to John and Steelcase for being such a great partner in our fall 2016 course, Greener Solutions. A little bit of overview for today. I'm going to keep my comments brief, thankfully, and I'm just going to hand it over to John and Mark. John is going to talk a little bit about Steelcase's collaborations overall, and then specifically collaboration with UC Berkeley. And then Mark's going to take over and give his perspective as a team member working with Steelcase on a challenge that they proposed. So just a little bit about the Greener Solutions program. We've been at it for about 5 years or so. We've partnered with about 17 different organizations on 8 discrete projects and trained about 50 graduate students and upper class undergraduates in interdisciplinary problem solving. We've worked with companies like Autodesk, Levi's, HP, and so on and so forth across quite a few different sectors, apparel, electronics, and so forth. And I just want to say that our philosophy behind the course really is it's project-driven, it's team-driven, it's very collaborative, but also we think that EHS performance should be part of overall performance for a company, and that often that's going to drive innovation. So I also wanted to give a real thank you to our other partners from fall 2016, Claudia Richardson of Patagonia. We looked at mosquito repellent clothing for them last fall, and also Allison Smieja of Mango Materials. We looked at non-toxic colorants for them in this same course. Our challenge for this course was a big one. It was an ambitious vision that I'm going to let John tell you more about, but basically, how can we get to some future vision of modular chemistry or polymer-based chemistry? In particular, we looked at non-toxic colorants. So without further ado from me, I want to introduce John and let him take over with the slideshow.
All right, thanks, Tom. Thanks, Joel. Happy to be here today. So Joel already introduced me, so I'll skip this slide and move on. So for anyone who's not familiar with Steelcase, we're about 105-year-old company at this point. We provide office solutions, whether that be furniture, some room planning and management equipment, and more technology solutions for offices. We consider it a pretty comprehensive portfolio that we supply to our customers through a variety of brands that you can see down on the bottom here. My role at Steelcase, as Joel already sort of mentioned, I joined in 2013 as an environmental chemist in our sustainability group. It's a really interesting position we sit in the company, because I was able in that role, and still am, to work with the entire value chain, all the way from 5 tiers deep in our supply chain to our customers, as well as these types of collaborations with academia and NGOs and things like that. So it's really sort of a broad view of sustainability across the company, and just recently moved into a role in our new sustainable design and development group. And our group focuses on several pillars of sustainability, mostly related to products, including eco-design, design for the environment type work, materials chemistry, recyclability and reusability, and also working towards a vision of circular economy. I wanted to talk about that just really briefly. So when we hear the term circular economy, a lot of people initially think of product circularity. So how can we keep the materials and products in circulation the longest so that we're maximizing the value of the materials in them? And that is important. We want to use safe materials that are perpetually cyclable. We've been designing products to the cradle-to-cradle design framework for 10 plus years now, and it's actually a model that fits really well into the circular economy. We also look at, like I mentioned, eco-design, designing our products to use resources efficiently and materials that are high value that can be used far into the future. But that also entails circular economy thought and vision at the facility level, whether it be limiting waste, deriving energy from renewable resources, protecting water, and also things like employee wellness. Those are all really important at the facility level. And then at the enterprise level, sort of building business models that can support the circular economy, things like product take back, resale of used product, remanufacturing. And also this sort of allows us to develop a new relationship with our suppliers and our customers to meet their needs as we try to move from a sort of a make, use, dispose linear economy to a what I like to think of as sort of a make, partner, and return or reuse sort of circular economy. And so those are all sort of the goals that underlie everything that our sustainability team is doing right now at Steelcase. So Tom was kind enough to let me sort of talk about all of our academic collaborations today, and some of them are really exciting. And I kind of look at our academic collaborations in three different buckets. There's sort of the outreach bucket, that could be, developing connections with NGOs or academia that we believe in, sponsoring their efforts, getting out in the community, things like that, whether it be local universities or other areas. And we also, will host events, develop content, etc. We also have the applied bucket. So that's sort of the, developing prototypes, really hands-on, trying to look at the near future. And then there's this last bucket, which I think is maybe a little less intuitive, but it's around opportunity mapping. And this is sort of looking at real problems that the company has in more of a future-focused way. So maybe, 5, 10, even 20 years down the road. And the good news for Steelcase is we're able to do that in some cases because we're a 100-year-old established company. And these opportunity mapping things sort of allow us to use the brain power of both sides. And that's what this opportunity with UC Berkeley Greener Solutions was, and we'll talk about that in a little bit. But as far as the first level of outreach, we work pretty closely with Beyond Benign, who I think a lot of people on this call are probably familiar with, and if you're not, you should look into it. It's a great organization. We've been working with them to develop curricula for K-12 educators around green chemistry, things that they can do in their classrooms that are inexpensive, but teach kids about the value of safe chemistry. We developed units or co-developed units on sharklet antimicrobial technology, ecovative materials, and our line of Cogent textiles that is both antimony free and has more thoroughly evaluated colorants and additives than a lot of textiles on the market. And we've also hosted a full-day workshop for high school teachers at our facility in Grand Rapids for the past few years, and we'll be doing another one of those in June coming up. So that's one example of our sort of outreach collaboration. When it comes to the applied stuff, we had a really cool collaboration a couple of years ago with Grand Valley State University, which is about 20 minutes from our headquarters in GR. there's a lot of research out there that shows that people are more productive, learn more, retain more when they have access to natural light and views to the outside. We also all know that there's a trend towards outdoor furniture and making outdoor work more productive. And so we worked with Grand Valley to modify our bivy bench to have solar panels and a battery so that you can actually be productive. The solar panels, if configured the right way, and if the desk is sitting the right way, it can provide shade to your desk so you can see your screen. The battery can power 1 or 2 laptops. And this was just sort of one of those prototypes that we worked on with an academic partner to see if it was something feasible for the company. And it sat out on our patio for a while for people to try. We had some feedback come in about, what's good, what's bad about it. So this is sort of one of those research-driven things that Steelcase did around applied sustainability. And then lastly, in these opportunity mapping fields, so we were lucky enough to work with the Center for Green Chemistry at UC Berkeley on this Greener Solutions course last fall. And I'm going to go a little bit more into detail on that collaboration here. So what's interesting about that is when we met Tom, actually at GC3 last year, and started talking to him about this, Steelcase didn't really have a challenge in mind, which it turns out to be kind of difficult, because then when you're asked to be part of this, you don't want to turn it down, but you have to come up with a challenge. And so he already talked a little bit about the Greener Solutions course in general, but we decided in a small group at Steelcase that we were going to take the long view on this challenge and sort of come up with a big, audacious problem that we wanted the students to work on. And as a result, what we came up with is a central question of, can we develop one polymer that fits most or all of our needs and products that can be safe, perpetually cyclable, and versatile? And for anybody who knows office furniture, this is a big, audacious goal, because we use several different kinds of polymers, a lot of different grades. They all have different additives and different technical specifications. And when we presented that to Tom and the team at UC Berkeley, they said, whoa, that's too big. We need to winnow it down a little bit. And so much like mango materials, we sort of ended up coming up with this idea of color. There's several reasons for that. One is that, colorants tend to have some toxicity concerns associated with them. But also it's something that the students can sort of visualize, right? It's a little bit more sexy than something like an anti-static or a UV stabilizer when it comes to polymer chemistry. So when we focused down, we decided to use our Node chair as an example. It works out really well because it comes in, I think, 19 or 20 different colors. A lot of them are really vibrant. Vibrant colors in my world tend to be the ones with the biggest concerns. And also, it's a product designed for the academic realm. I think they actually have some Node chairs at UC Berkeley. So this was sort of what we landed on in our challenge. And I think Mark's going to get into a little bit more detail about what we actually talked about, what some of the solutions were. But there were some challenges that went along with our goal, our project here. It was very future focused, and that made it difficult for the students to sort of dig into the literature and find any precedent or any sort of research that was already out there on this problem. So that made it difficult from their end. It's also the Node seat shell is polypropylene, so it's really difficult to functionalize. That was something that we didn't really think of in advance as we were coming up with the specific case study. And so that sort of raised a barrier to creativity as well. And then it turns out that the challenge you choose is really important. We were thinking from the perspective of what challenge can we propose, rather than thinking of the desired outcome or the why we're choosing this challenge. And I think that's really important for any industry that's going to get involved in an academic partnership, is to really flesh out the why of your question. So you can pose it in a way that opens up creativity, but also helps the academic institution focus on what you're looking for in the end. It was also a challenge because this chemistry, the actual additive chemistry to the polymers is not something that Steelcase does. That's something we work with our supply chain partners on. And so we weren't really in the best position in this supply chain to answer all of the students' questions. And we also didn't have all the experts sort of lined up in advance. And I think that would be important going forward to make sure you know what kind of experts you're going to need to make sure they're ready and willing to speak with your team as you move forward. And then there was also, you know, I don't know if this was a challenge because it was exciting for me, but you have to be able to set aside time to actually have discussions. Mark and the team and I met pretty much weekly throughout the semester to go over questions, get progress updates, and things like that. That being said, there's a lot of really cool opportunities when you get into a partnership like this. I think with a well thought out challenge and the expertise of a university like UC Berkeley, you can really come up with a really interesting opportunity map, a really interesting discussion starter with your suppliers or your formulators, and it can really get the discussion started about green chemistry when you're talking either internally at your company or externally with suppliers and customers. It was also really cool to be able to make some connections, however brief, with the people from Patagonia and Mango, just building that network of people that are interested in green chemistry. And I think if your challenge is set up correctly, you can really inspire creativity and future thinking for both the students and the manufacturer. And I think that's sort of a barrier that needs to be overcome. Sometimes we get into these tunnel vision thinking tracks, and it's hard to get out of those. And a project like this really allows you to think bigger, think broader, and think about something different than you usually would. And so that's really all I had to talk about today. I hope we can answer some questions. Thanks everybody for joining. And now I am going to turn it over to Mark for his portion.
Wonderful. Thank you, John. So I'm going to give my take on the Greener Solutions course from fall 2016. This is the team that worked on the Steelcase challenge. So Joel introduced myself, and the other team members were Cecilia Henspringer, who is doing a PhD in the Energy and Resources Group, and she's studying energy policies in Asia. And she previously worked as a consultant in a climate and environmental policy firm in Washington, D.C. And then the other team member was Laura Armstrong, and she is doing her PhD in science and math education, where she's developing green chemistry and toxicology lab curriculum. So as you can see, we were a very interdisciplinary team, and we worked quite well together to attack the challenge that Steelcase brought to us. So I can speak to why I took this course, and I think it resonates probably with many other graduate students in the course. This course was not a requirement for me to take for my degree. I'm currently a fifth-year graduate student and probably should be working more on my research, but I thought it was still very important for me to take this course. First, for my own personal professional development. The experiences that I would get through this course were very valuable. So that's the teamwork, the client relationship building with Steelcase, and then the technical communication, both written in our written report at the end of the course and throughout the course, as well as our oral presentations. For me, it was also a chance to explore potential career pathways not within academia, in the realms of social responsibility, as well as research and development. And then the final reason relates to, in a PhD, your research is so focused on one very specific topic that it can still be very interesting to broaden that knowledge set and to learn about another topic. And that was very interesting as well. And so this slide here kind of explains the approach to the Greener Solutions course and the structure of the course as well. So we start with the Partners Challenge, and John mentioned how they came up with their challenge, and so that was presented to the team. And then from there, the team works on understanding the chemical functions behind the Partners Challenge. And this is really the heavy understanding the chemistry part of the course. And then you have to understand the design constraints. And oftentimes you have competing design constraints, and you have to try and understand how they all function together. And then the course directs us to look for bio-inspired solutions to some of those design constraints, and look to nature to solve some of those. In our case, we were looking at polymer functionality. We didn't really turn to bio as much as really the heavy chemical literature. And from there, we identified alternatives, or rather strategies, to the challenge. And then we did an environmental assessment. So this was mainly just a hazard assessment and less on the risk. And that was really just based on the time of the course. And then we were able to provide an opportunity map to Steelcase. And John mentioned the opportunity map, and we did that both as a written report as well as an oral presentation. So I'm going to talk about, is this going to work? There we go. About the project. So John introduced the project a little bit, and so this was the statement that we came up with in our team is, and can color be imparted to a polymer without a free-flowing additive? So that idea incorporates the modifying the polymer backbone and functionalizing the polymer backbone with the idea that the colorant is kind of just this additive, and you could, in theory, do it with any other additive as well. As John mentioned, and I think we have the same figure here, we use the node chair seat shell as our model system. Okay, so I'm just going to talk about some of the challenges that we faced. The slide got a little cut off, but that's okay. So the first challenge we faced was identifying an achievable goal. And John talked a little bit about that within the company but there was still a lot of discussion that our team had with John, where we tried to really understand the underlying motivation for Steelcase's vision, and then had to figure out a problem that we can attack, that we can approach in our team. And then our team had a lot of discussion about finding a goal that had academic merit, that was interesting to solve, that someone would be interested in. And then, as John also mentioned, we had a challenge with learning the necessary background. So there are lots of topics within this challenge, polymers, the molding of polymers, the colorants themselves, and the timing. It was very difficult for us to meet with the industry experts. We were able to meet with some of the engineers at Steelcase. As well, we met with a local USDA scientist who happened to be working on coloring polymers. And then, of course, there's this factor of time that plays into all of this. The course was a 17-week course, and that's the project. But the instructors really do a good job of developing the teamwork and setting a pace to the class. And one thing that we did as a team was set our goals. And one of them was that we really wanted to produce a good report and to do really good work for Steelcase. And of course, those are conflicting constraints where we have 17 weeks to provide a really good report. So that also plays into the limited time to meet with industry experts. So now I'm going to talk a little bit about the strategies that we came up with for solving that coloring case. And there's two kind of separations here. One is along the bottom, you can see that we have a timeline for the near term all the way to long-term solution strategies. And then on the top, the strategies are separated. On the left-hand side is the less hazardous additives. And so this was really a straightforward replacement for carbon black. We looked at torrefied walnut shells. And then on the right-hand side, these are strategies for adapting the polymer backbone. So we have grafting polypropylene, which is basically breaking a polypropylene backbone and inserting whatever molecule you wanted to at that broken spot. The next strategy was using maliated polypropylene, in this case, it's commercially available polypropylene that already has maleic anhydride incorporated into the backbone. And in this process, you would bind directly to that the maleic anhydride within the backbone. And then our last strategy, which is on the far end of long-term, is using peptides that can specifically bind to polypropylene and then attaching a additive to the end of that peptide. So this strategy still requires a lot of research to understand the mechanism and how it works. And we were very clear about that in our reports. We went one step further and looked at the supply chain for Steelcase and how our strategies would be implemented within that supply chain. So this is basically a diagram of our interpretation of the supply chain, starting with Steelcase supplying the node chair, and then moving down through the supply chain. So the polypeptide binding, the polypropylene binding peptides, depending on the mechanism for their use, could either be applied after the seat shell was molded or before in the molding process. Then the grafting of the polypropylene would occur after the resin was made, before the molding process. The meliated polypropylene it adds an extra step in the production of the polymer resin, and then another step after the polymer resin is made to then attach your colorant to that meliated polypropylene. And then the last strategy, again, is a simple replacement of the additives all the way down in the supply chain, replacing carbon black for the torrefied walnut shell. So I'm going to talk a little bit about the opportunities within the framework for greener solutions. John might have touched on some of these points. So for a partner challenge, as I outlined the structure of the course earlier, the course works really well for investigating less hazardous alternatives to a hazardous chemical within an industrial process. So that's kind of contrary to the challenge that we had, which was really investigating an industrial process itself. And so we found that very challenging. That's not to say that we didn't succeed. I think we did succeed and produced a really great report. But it was difficult at times to fit it within the structure of the course. And then on collaborating, John also mentioned that he met with us weekly, and that was crucial. We were very lucky that we had these meetings with John, and we were able to get the feedback that we needed, especially right at the beginning when we were really working on producing a goal for us. That was not the case for some of the other teams, for some of the other groups in the course. And then the last one, which John also touched on, was getting that background information right at the beginning would have been beneficial to us because the structure of the course, there's a very fast pace of the course, and there's always something new you're working on. So it's important to get that background information. And just briefly, the impacts as a PhD chemist, it feels really good to have an impact on real-world problems. And then connecting the industry to the isolated academic research was also illuminating to me. You know, there's so much academic research that we have access to at UC Berkeley here that industry just doesn't have access to. And then the last impact here was, you know, I was able to meet my personal goals, gaining valuable experiences that I mentioned at the beginning. And with that, that's all that I have. So I think I'm going to turn it over to Tom to field any questions that anyone has.
Great, thanks, Mark. And then I guess if we've taken questions through Joel, we're take some. I have a question first for John, though. John, I was wondering if you could relate these, let's call them interventions, if you will, to your manufacturing process and tell the folks a little bit more about the master batch process and how these interventions really going to relate to your manufacturing.
Yeah, that's a really good question. So currently most of our molded plastic parts have either a solid or a polymeric master batch added to them at the time of molding. So that would be, if it's a polypropylene part, generally polypropylene pellet that has a heavy loading of colorants that then get dispersed throughout the part during the molding process. Or in some cases, as with the node seed shell, it's actually a liquid master batch that's injected at the time of molding. And I think the sort of big challenge with this idea of imparting color in a different way is that it would likely affect the molding process. So right now we have some black or gray parts, for instance, that are pre-colored plastic and there's no master batch added. And that would likely be the scenario if you were using any of these sort of future-focused polymer backbone modifying solutions that the team came up with, is that you would be pre-coloring the plastic, so all the pellets would have the color that you were looking for already. And it actually could serve to simplify the molding process in some ways if they were able to withstand the high temperatures and the conditions of the molding process. So it's actually really interesting because it would sort of affect us at Steelcase further down or upstream, further upstream, a couple tiers deep into the supply chain where they're actually formulating the polymer itself.
Great, thanks.
So Tom, I have a question from the questions, and just remember that if you do have a question, use the questions box on the side of your screen. One question for John and Mark was, what's the near-term option that the walnut shells implemented by Steelcase?
Was it implemented? Is that the question?
Yeah, was it implemented? Yeah.
No, not yet. So I can tell you that being in a global 100-year-old company is good for future thinking, but it can sometimes mean that implementation of these things is a little bit slower. So that will, in order to start using that solution, if we were to go that route, it would require, working into our supply chain, testing for color fastness, and there's a variety of testing that would happen. And so when we say that solution is near term for us is a year or two, and the longer term solutions that Mark presented are more like 10+ years of development. So there's some time baked in there that hasn't passed yet.
Great, thanks, Tom. Well, let me ask another question of both. Well, all three of you. What are the most important lessons from this, and how would you take what you've learned to improve these academic industry partnerships in the future?
Well, I could start on that. I think we definitely heard the message loud and clear about taking more care and looking at the tiers of the supply chain in the material challenge that we're looking at and setting that up from the beginning. That's a big lesson I've taken away from this particular round, that we really need to make sure that we give enough support from this end, the academic end, to the partner or the client in setting up an understanding about how deep into the tiers do we have to go, who would be willing and committed to answer technical questions at those tiers, and how can we impart that in the quickest way possible. As Mark mentioned, the pace is very fast. It's only owing to the real intelligence and creativity of the Berkeley students that this course really works, quite frankly. They're very capable. They hold up to the fast pace that we impose on them. But I think for me, as one of the co-teachers, really that was a big lesson from this, just sussing out those tiers of the supply chain, those contacts, making sure that the technical information that's necessary or critical really gets imparted.
Yeah, this is John. I'll add, you know, this is a really great opportunity for a manufacturer to get out of that normal, you know, run the business sort of thinking. And I think one way that it could have, you know, I mean, it was great for us. I think we got some really good ideas from the team. It was a really good collaboration. But one of the ways that it can always be improved is like I said, if the manufacturer has a really good challenge in mind at the time they get asked to do this, rather than having to come up with one, you're a little bit under the gun. You know, I would say that for most manufacturers, we have a pretty large number of green chemistry challenges that we could pose. And it just turns out that, you know, when you're looking at the long-term and opportunity mapping type structure, that number starts to dwindle of opportunities that is really fits this type of course. So the one thing I've already sort of encouraged Tom to do going forward is, you know, maybe put out a call for proposals to companies before the semester, so that companies that already have a challenge in mind could pose it, rather than finding manufacturers and then trying to find a project from there. But
well, I'm going to pick up on that right away and put in a plug for fall 2017. We are already have decided a category of challenge. We're going to look at perfluorinated compounds. We already have one startup company that will be a partner, but I put it out there to GC3 and all its members that if you do have a challenge related to perfluorinated compounds, whether in you know, fabrics or building materials or furniture, please let us know and be happy to talk to you about that.
Great. Other questions from our, we do have another question. Did the team consider structural rather than chemical options using phenomena like iridescence to impart color similar to Sharklet?
So we...
Go ahead.
Okay, yeah. So we did certainly consider structural color. We got feedback from John saying that that's not really a technique and a strategy that they're interested in. So that was very crucial feedback that we were able to get in our weekly meetings. Structural color is generally on the outside of products, and it's susceptible to damage from wear and tear, and especially using furniture that people are sitting on can easily be damaged. So we did not look further into structural color than that, really.
Yeah, and I'll add on to that really quickly. I think part of that guidance from Steelcase was based on the product we had chosen. I think if we looked at the broader universe of polymers that we use, there are definitely some applications where that type of thought process would be really useful. It's just this is a seat shell in a high wear environment of, generally K-12 students. And so you have to make sure that anything you're putting in for color is not just on the surface and really holds up well.
Well, that's a good additional question back to Mark. Having been primarily in an academic setting, hearing these these requests from Steelcase, including performance, etc. Did this sort of bring you out of your comfort box or knowledge box? Because now it's like, this is real. There's performance needs. There are characteristics you need to meet.
Absolutely, for sure. I didn't show our entire report here, obviously, but in our report we did talk about the performance constraints. There are a lot. I'm not an engineer, but there were a lot of different engineering metrics to what the polymer needed to meet. That was something that I didn't know and had to learn about. But we were able to address how our strategies may or may not affect those constraints. We did not do any testing in the lab. We did not have concrete answers to those questions, but we certainly did consider them. And yes, that's not something that I normally do in my day-to-day research.
And then, John, let me ask you the opposite question. You know, working with, you know, one of the challenges of working with students is many of them have never been in the real world and understood the requirements that you have for, you know, the furniture that you're manufacturing. How have you seen, despite the sort of, I would put in quotes, greenness of students in chemistry, have you seen the ability through this project to sort of get what you need out of that?
Yeah, that's a really good question. It was interesting to me to work through this process because, and I think Mark can probably attest to this too, our early conversations between myself and the team tended to be sort of more far-reaching, broad. There was a lot of solutions suggested that may not meet the manufacturing and technical requirements. And as we worked through the semester, we were able to sort of hone in on solutions that may work. And what's really cool about that is, you know, you try as the manufacturer in this course not to be too limiting, because you want to make sure that good solutions are being considered and you're not using your sort of narrow, pessimistic focus and turning off the creativity of the team. But at the same time, you need to be on the other, you know, sort of that devil on one shoulder, angel on the other sort of idea of making sure that the opportunity map, the report that you get out of this is going to be useful for conversations internally and externally. And I think I saw, you know, our team, I was really lucky to have the team that we had because they were really willing to take that feedback and really sort of go through iterations of their proposal and their ideas based on the conversations we had. So it was, the collaboration side of it was really good from that perspective.
And I'll just add to that, if I may, just within the course by design, we definitely put forward the idea that all of the recommendations should be actionable, so that the students spend a lot of time with the partners, finding out what those constraints and opportunities are. But also we encourage them in their own fashion to present a range of options, from low-hanging fruit to blue sky options, so that the partner can pick and choose, and also it also produces a richer discussion, I think, with those kind of boundaries, if you will, a richer discussion for innovation. So we do try to design it, bake it in for actionable results and impact. As Mark had mentioned, they spent some time thinking about, well, what is a good question to have? Forming that problem statement is very critical to the study. Just along those lines, I know we have to wrap up here soon, but I wanted to ask a question of John and Mark, just about what demands further study from this. This, of course, is not the end of things. It's perhaps a good beginning. As I say, these things can be followed up and acted upon. But what out of this study do you think demands further study or action?
I mean, I can start just kind of talking about the strategies that we laid out. None of the strategies that we laid out are currently commercially used in a manufacturing process on a large scale. So that is certainly a next step that can be done. Not something that really within the purview of the Greener Solutions course that I was a part of last semester, but I think as part of our report, we did lay out kind of the next steps in questions that need to be answered kind of on each one of the strategies in order to move them forward.
Yeah, and so I think a lot of the next steps are sort of on me and on Steelcase to look at them. You know, the course focused in on color of one seat shell, but I think some of the solutions that were provided by the team actually may have applications to some other challenges we have with polypropylene in general. And so I think next steps on our side are to sort of, you know, maybe really look into the walnut shells thing, because we are interested in carbon black alternatives and have explored some of those in the past. But as far as some of these polypropylene modification strategies, those actually might be good conversation starters with our suppliers in some other instances that we're trying to work out. Maybe not necessarily the colorants at this point, but whether it be, you know, modifying surface tension or strength properties, things like that, that we might be able to use some of those solutions and apply them to other problems. And so, you know, we're sort of looking into what the best ways to do that, who the best supply chain partners are. And then also, you know, I know this is a little bit less proactive, but putting this report in our sort of toolbox of green chemistry solutions that we have at Steelcase for when the next problem comes up that's similar to this, we can say, oh, you know, we've got this research from our Greener Solutions collaboration that we might be able to apply here.
Great. Over to you, Joel.
Oh, well, thank you, Tom, John, and Mark. This is great. Really excellent case example of the opportunities for collaboration and partnership between academic institutions and companies to accelerate green chemistry solutions. So with that, we'll wrap up the webinar. Thank you for joining us today. Thank you for all your efforts at the Berkeley Center for Green Chemistry, and obviously Steelcase for collaborating with academic institutions to bring forward the next generation of highly trained green chemists. And we look forward to seeing everyone in about a week and a half at Steelcase for what is going to be an excellent 12th GC3 Innovators Roundtable. So thank you, everyone, and have a wonderful afternoon.
Thank you. Bye-bye.
Thanks.